Hallo, it's dumplet here. Here's an item on geometry. ABCD is a square with area 64, P is on BD. Find the minimum value of AP plus PE. Credits to the Southeast Asian Math Olympiad for this item. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now, there is a very clever way to do this, and it just involves around a very simple concept. Now, before that, we want to note AP plus PE over here, and honestly speaking, it's not that easy to get what the minimum value of AP plus PE is, so let's try to write this in terms of something that we can work with. And the first step is going to involve some reflection. In fact, we want to reflect this point E across this line BD. So we're going to reflect E across line BD to get another point here. And let's try to see what's going to happen after we do that. So reflect E across reflect E across diagonal BD. So I'll get E prime. Now we can have the following observations. Is that, well, thanks to symmetry, EB will be equal to BE. So in fact, it's already given that the square has an area of 64, so just get the square root. The side length is 8. So we can already conclude from this that EB here should be 2, which will then make BE here equal to 2. So that's the first step. And what we can notice here is that AP plus PE is the same as saying AP plus PE prime. So we just want to find the minimum value of AP plus PE prime if we can. And we can use the very nice concept here, because AP plus PE, at least in this figure, it should be greater than A prime because of the triangle inequality theorem. But there is an optimal way to do this, and that is to make A, P, and E prime be collinear. And that is the optimal way. We want them to lie in a line, so that at least the triangle inequality would reduce to an equality, so that the 3 points A, P, and E prime will be collinear. And we know that this is the optimal strategy because A and E are fixed points. We can't really move anywhere. We can't really move them anywhere. The only variable point here is P. So in fact, it would be very optimal for us to place P on this diagonal BD such that it's going to be collinear. At least AP E prime will be collinear, and to do that is relatively simple. All you have to do is draw segment AE prime and then their intersection. Let's call it P suboptimal for the optimal point. So let's label this as the optimal point. So the minimum value of AP plus PE, which is also, we can also replace PE by PE prime. So that's simply going to be equal to AE prime. So it suffices for us to just get the length of AE prime to find the minimum value. So it's not that difficult. All we have to do is to rely on the Pythagorean theorem. Why? Because we have a square and we have a lot of right angles. This angle is right, so we can easily focus on triangle ABE over here. It's obviously a right triangle, so we can just apply Pythagorean theorem here. So AB, it's given to be 8 because the area of the square is 64, so the side length is equal to 8. And then BE, by symmetry, since EB equals 2 from the given that A equals 6, so EB equals 2, hence making BE prime equal to 2. So just get the Pythagorean, just use the Pythagorean theorem to get the length of AE prime. So AE prime would equal square root of 8 squared is 64, 2 squared is 4, 64 plus 4, that's square root of 68, and we can write this in simplest terms as 2 square root of 17. Therefore, the minimum value of AP plus PE would be 2 square root of 17. And this is our answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!